factor and solve quadratics in the form of ax squared plus bx plus c when a is not equal to 1, and this is from section 8.7 in your book. So first, let's review something about FOIL, because this is really, if you don't understand this, then factoring is not going to make sense. Let's say that I had 2x minus 5 times 3x plus 4. Let's multiply these two using FOIL, as I've showed you. FOIL, we're following an acronym. First, outside, inside, last. So we multiply 3x times 2x, and I get 6x squared. I multiply positive 2x times positive 4 and get positive 8x. I multiply the inside terms, get negative 15x, and I multiply the last terms and get negative 20. I combine my two middle terms, and I get 6x squared minus 7x minus 20. So this is a quadratic in the form ax squared plus bx plus c, just like this. And what I want you to see is that today we're going to be given this, and we're going to factor it back into these two binomials. And the process is called the product sum method. And you need to be familiar with that term because you'll probably hear it some more while you're in high school. So let's get started right into some examples. I have 3 examples for you today. And the first 2 we're going to factor, and then we're going to solve one. So let's say that I am asked to factor this quadratic 2x squared plus 15x plus 18. Once again, we're going to make a chart just like we did before, and instead of factors and sum, I want us to think product and sum, but we're still going to list some factors here. So let me see if I can't squeeze that in. Okay, so the reason it's called product sum is because the first thing that I do is I multiply the a term, 2, times the c term, which is 18. So I always do a times c, and make sure you pay attention to the signs. So 2 times 18 is 36. So what I want to do now is list the ways that I can multiply two numbers and get 36. For example, 1 times 36 is 36. But when I add those two together, I get 37. What is the sum that I want? Just like before, it's 15. Okay, positive 15. So what if I did 2 times 18 to get 36? 2 times 18 is 36, but those two add up to be 40. That doesn't work. How about 3 times 12? 3 times 12 is 36, and 3 plus 12 is 15. That's the combination we want. So what we do now is we rewrite this quadratic. The first term and the last term stay the same, but we split up this middle term into the two numbers that we just found, plus 3x plus 12x. Okay, notice the 3 went here, the 12 went there. And then we do the factoring by grouping method that I showed you, where we split this thing in half. This was back a couple lessons, so this will be good review for us. What I do is on each of these separately, I do backwards distributive property. I pull out the greatest common factor. So on these two terms, the greatest common factor is there's an x there. What I'm left with is 2x plus 3. Think backwards distributive property. x times 2x is 2x squared, x times 3 is 3x. So what I told you is that if this works out well, this 2x plus 3 should also be over here. Let's see if it works out that way. What's the greatest common factor of 12x and 18? It's 6. Is 6 times 2x 12x? It is. 6 times 3 is 18. And notice this was a positive 6. So once I get this far, the work is done. I now look at the entire expression, and I look at the whole thing, and I see that there's a common factor here and here that I pull out, 2x plus 3. What is it multiplied by? It's multiplied by what is left, x plus 6. And that problem is now done. Okay, so once again, product sum method, we multiply the a term times the c term. Then I want the factors, things I can multiply together to get what I got when I did a times 6, or I'm sorry, a times c. And then I want the two numbers to add up to be this middle term. Let's do another one of those so that you're more comfortable with it. Let's say that I had 3x squared minus 3x minus 18. So once again, we're going to make a chart over here. We're going to always have a sum, and we're thinking product sum method, so I'm going to put product sum even though we're listing factors. So I do 3 times negative 18. 3 times negative 18 is negative 54. So I want two numbers that multiply to get negative 54 but add up to be negative 3. Okay, two numbers that multiply to get negative 54 but combine to be this middle term. So how about negative 27 and positive 2? Those two multiply to get negative 54, but when I add them up, I get negative 25. That doesn't work. I want a negative 3. So I need the numbers to be closer together. How about positive 9 and negative 6? Those two multiply to get negative 54. When I add them together, I get positive 3, but I need a negative 3. So let's flip the signs around. Negative 9, positive 6, there we go. That's the combination that I want. So I rewrite my quadratic now. Remember, the first term and the last term stay the same, and then I change the middle term to these two numbers. I change it to two terms, negative 9x and positive 6x. I'm doing the factoring by grouping method, so I'm going to pull out the greatest common factor of these two, which is 3x, which leaves me with x minus 3. I'm hoping there's going to be an x minus 3 over here. When I factor out, there is a 6 in both of these. 6 times x is 6x. 6 times negative 3 is negative 18. We're in business. So this thing factors into x minus 3 times what's left, 3x plus 6. Now, if they tell you to solve it, everything is the same, but then we just solve it like I've shown you using the zero product property. So let's do one of these. This one we're asked to solve. Let's say that I am asked to solve 12x squared plus 3x equals 2 minus 2x. Well, what I've told you is that when we solve a quadratic, we want it equal to 0. This thing is not equal to 0. So let's do a little bit of algebra here to get it equal to 0. So I have 12x squared plus 5x equals 2. I need to subtract 2 from both sides. Now I have 12x squared plus 5x minus 2 equals 0. Now it's equal to 0. Now I'm ready to solve, and guess what? It's just like these last two problems that we did at this point. So we're going to set up a table, product and sum. Remember, we're also looking for our factors. Product and sum. I multiply 12 times negative 2, and I get negative 24. So I want two things that multiply to get negative 24, but combine to be positive 5. So, multiply to get negative 24. How about negative 6 and positive 4? Those two multiply to get negative 24, but when I combine them I get negative 2. That's not going to work. How about negative 8 and positive 3? Those multiply to get negative 24. They add up to be negative 5. I think we're close here. Let's flip the signs around. How about positive 8 and negative 3? There we go. That's the combination we want. Multiplies to get negative 24. Combines to be positive 5. So I rewrite this thing just like we did on the first two examples today. 12x squared plus 8x minus 3x, and this last term always stays the same. We are solving it, but we'll worry about that in a minute. We do the factor by grouping method, so we're going to split this thing up. I'm going to pull out the greatest common factor here, which is 4x, and that leaves me with 3x plus 2. I'm hoping for a 3x plus 2 over here, and I can have a 3x plus 2 if I factor out a negative 1. Look, negative 1 times 3x is negative 3x. Negative 1 times positive 2 is negative 2. That works. So I pull out the 3x plus 2. That's going to be multiplied by what's left, 4x minus 1. This happens to be one we are solving, but we have talked about this. The hard part is done. We now split these into two separate little equations to solve. 3x plus 2 equals 0, and 4x minus 1 equals 0. And I solve them both separately, and I get two answers, which we said earlier in the week represent x-intercepts. I'm out of room here, but I think you can see that x equals negative 2/3. And over here, I add 1, I add 1. 4x equals 1, so x equals, when I divide both sides by 4, x equals 1/4. And we will stop the video there for today.